In this video, I'm going to introduce Radicle Artifact and walk through the workflow of using it. Radicle Artifact is a way to do secure distribution for artifacts with Radicle. And the key idea is that every artifact is content addressed and signed. It is modeled as a collaborative object, just like issues and patches in Radicle. It is multi-party, allowing signing and attestation by more than one party, giving you some of the transparency that you get from transparency logs. And finally, it is also transport agnostic. It ships out of the box with HTTP and IRO blob support, giving you both the power of like traditional HTTP hosting, while also giving you the peer-to-peer powers of IRO and IRO blobs, allowing you to do things like NAT traversal, and all of this works out of the box. For this demo, I'm going to give a real-world use case where I have a Parquet dataset from the World Bank, which is published publicly. And what I'm going to show is how I register that artifact in the repository and how I distribute it, fetch it on another machine, and then run some queries against it. So let's get right in. And here I have this repository. As I mentioned, there's this world development indicators Parquet file. Parquet file is just a way to store information. You can think of it as something similar to a CSV if you're not familiar, and you can also open it with DuckDB. So for example, I can run a query against this file, and if you see the query that I just ran, it runs an SQL query against this file. This is really convenient for distributing datasets. Okay, now we have a Git repository with an initial commit, but if you look at the tree here, the Parquet file is ignored. And if I show you the size of the file, you will see that it's 61 megabytes. Now, 61 megabytes is the kind of file that you could probably push into a Git repository, but Git was really not built for this kind of thing, and this is where something like Radicle Artifact comes in handy. Now, obviously, there's existing solutions like Git LFX, Git Annex, and there's also a proposal called Large Object Promises. I'm not going to get into the nuances in this video, but if you go to the repository, you can find this document that gives you a comparison about how they differ. But the key idea is that, like Radicle, it is decentralized, and it does away with this notion of a single canonical server that is responsible for serving the artifact. And so you can have for each artifact multiple locations, and I'm going to demonstrate what that looks like in practice. The second key difference is that Radicle Artifact gives you provenance in addition to distribution. So what does provenance mean? It means that you can attest and verify cryptographically who signed off on this artifact and what is its origin, to which commit is it tied, and which tag optionally, like an annotated tag in Git. And so you can do that in a way that builds on top of things like canonical references, where you can require a minimum number of maintainers, also known as delegates, to sign off on a tag before it's considered canonical. Now, if you're also not familiar with canonical references, I will also share a link to a new blog post that we just published that covers all of the ins and outs of canonical references. This is on the Radicle Garden blog. So we have this Git repository, but it's not yet a Radicle repository. And to make it a Radicle repository, we're going to run the rad init command, and it's asking for a name and a description, and the default branch is main, and this is public. And now we have the link to the repository, and this is now viewable on the Radicle network. That's great. Okay. So we have this repository, and then the first thing that we want to do is to register this dataset. We're going to keep things simple. So the first command that we're going to be used is the register command, and the register command accepts a file. We're going to give it a revision, and the revision is just going to be the current commit. And so it's asking me for the artifact name, and I'm just going to go with the default. Okay, so now we did the first thing, which is just the registration. No bytes, so to say, have moved. The only thing that it did is it registered it in a COB, a collaborative object, which means that anyone now who has this repository can discover this artifact, but it can't download it. And so the way to see this is we can run the list command and it will tell you, hey, we have this release that is tied to this commit and it has this content ID. Now, if you're not familiar with content IDs are like glorified hashes. There are hashes that contain some additional metadata in the string about what kind of data it is and what kind of hash function. SIDs are a concept from the IPFS world, and they're a really useful way to build these content addressed systems. Okay, so we have this content ID, and that allows us to also verify the integrity of this file when we fetch it. And what we see here is that there are 0 locations, and that is because no one is seeding it yet. And now, in theory, we could add a location, and we have this hint here from the output. We could upload this to an HTTP server or to S3 or any kind of blob storage and then add a location, and then folks would be able to download it. But we want to do things a sort of the more native way. And this is where the rad artifact node comes in handy. And so I already have this node running. This is a long-running daemon, a process that handles all of the moving of these artifact bytes, which are actually synced either using HTTP, as I mentioned, or using IRO. IRO does reliable peer-to-peer connectivity, and using IRO blobs, one of the IRO protocols, it can handle the transfer of the file, even if you're behind NAT. And as I am in this case, and we're going to see that in action. And so I have this node running, but usually in order to start it, you run node start, and obviously it's telling us that it's already running. And great, so the next thing that I want to do is I want to seed this file, and seeding will actually import it into that long-running process. And the second thing it will do is it'll register a location. And so if I do list now again, you will see that it shows up 1, and it also has this little seedling here, and that is to indicate that we are in fact seeding this artifact. Okay, another interesting command that might be useful is the show command. You need to pass it either a revision or a release. I can also just pass the commit here, and it will show me this. And as we can see, we have this one artifact, and you can also attach metadata. By default, we attach the size bytes key and just give a size hint so that anyone fetching the artifact can know approximately how big the artifact is before fetching it. But this is just a hint. Okay, so now I am going to go to my second remote machine, and on this machine I'm going to clone this Radicle repository. And so I'm going to copy the repository ID, and I will enter the dev folder, and here I'm going to go rad clone and pass it the repository, and there we have it. Now, if I go into the repository, you will see that I don't have this Parquet file, and so if I try to run, these DuckDB queries, they will just not run because the file cannot be found. Great. Now, I am going to check if I have the node running on this machine, and I do, which is great. So now I can do rad artifact list, and I see that it's 1 location, but as you can see, I don't have the seedling here. And that is because I don't have it locally. So in order to fetch it, I can run there's 2 interesting commands. There's the fetch, and then there's the download. There's an important nuance between the 2. Fetch only fetches the artifact into the local store, whereas download does an additional step of actually exporting it from the store onto your file system. And so for this, I'm going to use the download. We try to make a lot of the commands here interactive so that you don't have to sort of start copying around a lot of hashes. And we can see here that we have this release, we have this artifact. And bam, what it's doing is it's trying this download location, which is a rad IRO location, and it's actually fetching this in a peer-to-peer fashion from my local machine, which is behind NAT. And if I run the status command, rad artifact node status, I will see that I had an active connection and it was also a direct. Now, there's a very good chance that it didn't do a hole punch because this machine, the remote machine, has a public IP. And so instead of having to hole punch, what will happen when you try to establish a connection between two IRA endpoints, if one of them is public, the private one that is behind that will just dial the public one, and a hole punch won't be necessary. Now that we have this Parquet file, we can run queries against it. Now, I'm going to rename this because it's put by default. I didn't give it an output flag. So it's put the SID as a suffix, and so now it's called the same as it does on my local machine. And now I can run duckdb -file, and then I have a bunch of queries here that I've already prepared, like, for example, this one, which gives us the richest and the poorest countries in the world based on their GDP per capita. And I've also been interested in Czech Republic these days, and so ran some interesting queries here. Like, how does the GDP of Czech Republic compare to some of its neighbors? It's 90% of the European Union. And there's a bunch more here, like the distribution of the full economy. I want to show one more thing, which is the cool part about Radicle Artifact is that you can have multiple download locations per artifact. And so if I go list, we see this one location, and when I run the download command, or the fetch for that matter, I can pass it an additional flag called seed, which will automatically seed it. Now, because I already have it in local storage, the only thing that it did now is it registered in the COB an additional location, which means that if I go list now, I should be able to see the seedling and 2 locations. Which means that now if my local node goes offline, isn't reachable, and you guys come along and you want to download this artifact, you can in fact download this artifact from my remote testing machine. And you can also seed it. You can also sort of add yourself as a location and increase the resilience. And so it really embraces this ideas of decentralization and participatory seeding. And of course, this borrows a lot of ideas from other peer-to-peer networks. Now, final thing I wanted to stress is that these locations, so for example, if I go show and what was the commit, there we go, then we can see that I have these 2 URLs. And as I mentioned, there's built-in support for HTTP retrieval and IRO retrieval, but really you can encode any kind of URL into this, like magnet URLs, which means that it allows you to get all of these like provenance, self-certifying data structures that are very similar to transparency logs, if you're familiar with like SigStore, and still do this in like a transport agnostic way. And so, you can have all of these artifacts being seeded by BitTorrent using these magnet URIs. So with that, I think this covers a very high level. I encourage you to check it out and share your feedback. And I will share some of the relevant links in the video description. So thanks for watching.